Hello, today we are covering lesson 11.3, areas of circles and sectors. You guys will be able to find these areas by the end of the lesson. Our new vocab is sector of a circle and segment of a circle. So section 1, areas of circles. In lesson 10.1, you learned that the formula for the circumference C of a circle with radius r is given by circumference equals 2 pi r. You can use this formula to develop the formula for the area of a circle. Below a circle with radius r and circumference c has been divided into congruent pieces and then rearranged to form a figure that resembles a parallelogram. So this shape looks very similar to a parallelogram. The only big difference is that these are curved versus just flat bottoms to the triangles, okay? So as the number of congruent pieces increases, the rearranged figure more closely approaches a parallelogram. So the smaller you make these pieces, the more close to a parallelogram this shape becomes. The base of the parallelogram is half the circumference because half of these are on the top and half are on the bottom, okay? And the height is the radius. So its area is, if we use base times height, half the circumference times the radius. And since the circumference is equal to 2 pi r, you can just plug that in for C, as it is over here. And you can reduce down to half times 2 is 1. R times r is r squared, pi r squared for your area. So if you look down here, the area of the circle is pi r squared. So in manufacturing, an outdoor accessories company manufactures circular covers for outdoor umbrellas. If the cover is 8 inches longer than the umbrella on each side, find the area of the cover in square inches. So they have a nice picture here for us. We know that our umbrella is 72 inches, but we actually just need the radius of 36. Then to find the radius of the whole thing, we go ahead and add 8 to it, so 44 inches. So area is equal to pi r squared. We just figured that out. We plug in 44 for our radius. We go ahead and take 44 squared. We get 1,936 pi. If it asked for exact solution, that would be your exact solution. Because it doesn't, I'm going to keep solving and find my decimal solution by multiplying 1,936 times pi. And I get 6,082, and I'll round to 2 decimals, 0.12 square inches. Okay? We'll do the same thing for the next one. A swimming pool company manufactures circular covers for above ground pools. If the cover is 1 foot longer than the pool, on each side find the area of the cover. So area is equal to pi r squared, which means we need to find our radius. The radius is 9, but we need the radius of the whole thing, which is actually 10 feet. So we go ahead and we have pi times 100. And if you take pi times 100, you end up getting, looks like I don't have it, 314.16. This is in feet squared. All right, pretty simple here. Now, if you are given the area and asked to solve for either the radius or diameter, you just have to work backwards. So you have area is equal to pi r squared. We know the area is 58. square inches. We are solving for the radius. Now don't freak out. Pi is just standing in for a number, 3.1415, so on and so forth. You can divide by that. So 58 divided by pi is equal to 18.46. I'm going to leave it as a decimal and use all of my places so that way when I round here at the end, I don't have any rounding error, and I get 4 point, it's going to round up to 30 for my radius. Notice it's not square inches, it is only inches because it is a radius, not an area. Similarly, for the diameter, I want to point out that r squared is not equivalent to the diameter. 2r is equivalent to the diameter. So when you solve for radius here, you'll have to multiply it by 2 to get the diameter. So we have that our area is equal to 45 square inches. I'm going to divide by pi. 45 divided by pi. Looks like I don't have that one either. Is equal to 14.32 r squared. Take the square root. We got our radius is 3.78, but we want the diameter. So we just multiply our answer by 2. And we get 7.57 inches for our diameter. Okay? So that is just area of a circle. And we can also find areas of sectors. A slice of a circular pizza is an example of a sector of a circle. So a sector of a circle is a region of a circle bounded by a central angle and its intercepted major or minor arc. The formula for the area of a sector is similar to the formula for arc length. If you look down here, you'll notice our proportion and our equations are set up. Instead of, like in the arc length area where we had arc length over our circumference equation, we now have area of the sector over the area of the whole circle. So it is very similar to our previous proportion that we used to solve for arc length. All right. So a pie has a diameter of 9 inches and is cut into 10 congruent slices. I'm going to do my best to draw out a circle with 10 congruent slices. It's probably not going to be perfect, but you'll get the gist. Oh, that was bad. It's actually not too shabby. Okay, so we know our diameter is 9 inches. It's cut into 10 slices. What is the area of one slice to the nearest hundredth? So we want to find, say, this slice to the nearest hundredth. Okay, so for our equation, we need the radius. That's easy enough to find. We know it's 4.5. It's half of the diameter. We also need our x value, or just one angle measure for one sector. The easiest way to do this is know that a circle has 360 degrees. You divide it by how many congruent pieces you have, and you get the degrees for one sector. Okay, so this is 36 degrees. We know our radius is 4.5. It's pretty simple to solve from here. You just go ahead and plug everything in. So you're finding the area of the shaded region over the area of the whole. Pi r squared over the angle of the sector over the whole entire circle 360. We go ahead and cross multiply to solve. Get 360a is equal to pi times 4.5 squared, which is right here on my calculator. That is 63.612. And then I have to multiply that by 36. You can do that all in one step if you want. On your homework site, at least want you to show out your setup step. I know a lot of these steps you can do in your head or just easily plug into a calculator, but I want you to show that you at least know how to set it up, because being able to let your calculator do it is not helpful if you don't remember what to plug into your calculator. So once you solve for the area, you end up getting that the area is 6.36 square inches. Now on this type of problem, there's actually a second way you could solve it. The proportion, it'll work every time. That's totally okay. You also know that this sector is 1/10 of the whole circle. So what if you found the area of the whole circle and then divided it by 10? So you could do that. You could do the pi r squared divided by 10 idea to find the area. If you look up here, once again, that is the area of the whole circle. You get 63.6. We'll say 6.2. You have to divide that by 10. And you get that the area is the same thing. Okay, so either way you solve it. For this particular kind, on our very last slide, you'll notice you can't do it this way. You'll get the same answer. All right? Now another good idea is you can check to make sure that you have the ballpark right sector area. We can find the area of the whole thing. These ones are easy to just completely check. You know this has to be 1/10 of that, so we just checked it here. We are good to go. But on other ones, if it's like less than half for the sector, you know it has to be less than half of the circumference. Things like that, all right? Let's do another one. A pizza this time has a diameter of 14 inches and is cut into 8 congruent slices. So 1, 2, 3, 4, 5, 6, 7, 8. We want to know what is the area of one slice to the nearest hundredth. So I need to find this degree. I know my radius is 7 inches. To find that degree, I take 360 and I divide it by 8 because there are 8 pieces, and that equals 45 degrees. And now I can plug everything in. So I have the area over the whole area, pi times radius squared, over my degrees, 45, over my whole degrees, 360. Cross multiply, 360a is equal to, let's see, 7 squared looks like I need to do it again. 7 squared times pi times 45 is equal to 6,927.21 divided by 360. And we get that we have 19.24 square inches as our solution. All right. The last three problems, we can't use the special way that I did up here in green because they are not congruent sectors. It doesn't tell us that. It just tells us shaded areas. So I use the same equation. I have area over my whole entire area. So area of the sector over the whole entire area, pi times the radius squared, equals the degree of the sector over 360. I cross multiply to solve. So 16 times pi, so that's where I got this. 16 pi times 53 is equal to 2,664.07. Divide by 360. I get my area is equal to 7.4 square feet. Part B, let me go ahead and shrink this down. We can do the same thing. Whoa. There we go. We can do the same thing. We have area over our radius, or sorry, area over our area of our whole circle. So sector area over whole circle area, pi times r squared, equals 148 over 360, this angle over the whole amount of degrees. Cross multiply. 360a is equal to, I'm going to have to do this again, 36 times pi times 148. Go ahead and divide by 360. And we get 46.50 millimeters squared. And this last one is only a little more difficult because they don't give you the shaded region angle. You have to take 360 minus 65 and get 295 to go ahead and set up the same sort of problem. Area of the sector over area of the whole thing. Pi r squared is our equation, so pi times 11 squared equals 295 over 360. Cross multiply to solve. 360a is equal to, probably a pretty big number, it sure is, 112,139.15. You'll see it right there is my work. I can go ahead and divide by 360. And I get that my area is equal to 311.5 square inches. All right. That is all I have for you today. Make sure you work through your problems, and you are good to go. Have a great day.